Prahlad, are you able to see my screen?
Yes.
Okay. So, we are starting a new unit that is Redox or electrochemistry. In order to understand that concept, let us first start and learn what exactly is redox in electrochemistry. Okay. So, redox
Okay.
is made up of two words. One is reduction and other is oxidation. Okay.
Okay.
I want you to copy this down. So, redox means reduction and oxidation. Reduction basically means gain of electron
And
and
oxidation is
oxidation means
loss.
loss of electron. In
Okay.
your textbook, you will come across a term Leo says Gar. Okay,
Okay.
in your
Okay.
textbook, they'll or in your school, they'll teach you Leo says Gar. So basically, Leo indicates oxidation, Gar indicates reduction. Gar means gain of electron. Leo means loss of electron. Is
Okay.
oxidation, gain of electron is reduction. Okay, can you write that?
Yeah, we're done.
Okay. Then, so basically, if you have a metal, right, that metal will take electron and it will have a negative charge, right?
Okay.
And if in case of oxidation, because it is losing electron, the metal, which is neutral, will have a positive charge. So you basically mean by reduction, you mean that there is decrease in the oxidation number,
Okay.
okay? And in case of oxidation, it means oxidation number is increased.
Okay.
Okay,
Okay.
done?
Yeah, yeah, continue.
Yeah. So these are oxidizing agents. So anything that undergoes reduction is an oxidizing agent. Anything that undergoes oxidation is a reducing agent. Okay. So understand this.
Okay.
Reduction is a process. Oxidation is a process. Right?
Yes.
Who carries out reduction? You need a reducing agent to carry out reduction.
Okay.
That means you need something who can take electron.
Okay, yeah, I
Correct?
get that.
Right? Is that understood? An oxidizing
Yeah.
agent is someone who will lose the electron.
Okay.
Does that make sense?
Yes.
So how do you understand? A reduction is a process of
Uh,
gaining electron,
Gaining electrons and
right?
oxidation is losing electrons.
Losing electron. So
Okay.
so basically anything which undergoes reduction will be a good oxidizing agent. Anything that is that can undergo oxidation is a good reducing agent. I'll repeat. If something is undergoing reduction, it is an oxidizing agent. If something undergoes oxidation, it is a reducing agent. This is the confusing part.
Okay.
Okay. So how will you remember? Agent,
Okay.
reducing agent, oxidation, oxidizing agent, reduction.
Okay.
Clear? So if the
Okay, so
term
vice versa.
agent, yeah, if there is a term agent that is added, you will just understand the process is opposite.
Okay.
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 I've mentioned the definition over here. Elements or compounds which undergo reduction are oxidizing agent. Elements or compounds which undergo oxidation are reducing agent.
Okay.
Okay. So same thing is been written in a different way. Oxidizing agent carry out oxidation, that is loss of electron, right? Reducing agent carry out reduction, that is gain of electron, right?
Okay.
That's done then. Cyanions, okay. So that's one part that we have covered. Okay, next I believe. So have you understood this part uh, about the redox?
Yes.
Okay, no doubt about it, right?
No.
Okay, now let me go to the textbook and we'll see what it is mentioned on the textbook. Okay,
Okay.
But if you have understood what we have done now,
Yes.
basically your 50% of the stuff should be clear.
Okay, okay. And in class, we're doing like redox reactions where you used net ionic equations and I was
Balancing
able
and
to
all
do it
that.
well. Yeah, yeah.
Yeah, okay, so balancing,
Then
right?
yeah, I was able to do it.
Okay, no problem. Let
Okay,
me let me go to the textbook first,
okay, okay.
and then you can tell me where exactly you need my inputs. Okay, so I will try to go step by step. Um, so it's electrochemistry. I'm not sharing anything with you, right?
No.
Okay, now I'm sharing the book with you. Okay,
Can we also maybe do, if we have enough time, balancing using half reaction method?
we'll do that. Yes. So
Okay, because
basically,
that's
now
what.
I'm coming to that.
Okay,
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 so electron transfer reaction, I have already covered oxidation reduction. Okay, that part is
okay,
done. What is oxidation reduction is redox. That is done. And now the next part is half reaction equations. Okay, so what are these
okay.
half reaction equation? Let us first understand that. So can you see this, right?
Yes.
Copper neutral is losing electron, right?
Okay.
So that means
Yes.
it is undergoing oxidation,
Okay.
correct? This is
Yes.
gaining electron. That means this is undergoing reduction, right?
Okay.
So this is one half reaction and this is another half reaction.
Yes, I understand.
Okay, so half reaction means in electrochemistry there are two reactions that are done. One is reduction, another is oxidation, right? So reduction is considered as a half reaction and oxidation is considered as another half reaction. And together that is a what do you say, uh, electrolytic or electrochemistry reaction or electron transfer reaction. Okay,
Okay.
any doubt?
No.
Okay, so this is what is called as a balanced redox equation when we combine them together. Okay, so what is the balancing that has been done over here? You have copper, right?
Yes.
Loses two electrons. Now if you see, there is the electron is missing, right? One electron is missing, so you multiply the entire equation by 2, so the electrons are balanced, and then you do the summation.
Is there another thing where if a solid loses electrons, it becomes aqueous?
Okay, yes, that is also true.
Okay.
Okay, so now please understand this part. I think I'll talk about that later, like how does a half cell is formed and the other stuff after the balancing is done. Okay, so now in this reaction,
Okay.
if you see aluminum solid, so there are two concepts in this. If you notice, first we need to identify that aluminum, okay, there is change in the oxidation number, and silver
Yes.
there is change in the oxidation number, right? So
Yes.
oxidation number of aluminum is decreased or increased
Aluminum
from
is
0.
is it's lost electrons.
Yes, it's loss of electron. So
Yeah.
loss of electron. So that is
And gold
LEO,
gained it.
gain of electron, right? Silver is gaining the electron. Okay,
Yes.
so you
Oh, silver,
have
not
your
gold. Yeah.
oxidation, right? So in oxidation you have aluminum, right? What is that doing? Aluminum, which is solid, is forming Al3 plus 3 electrons, correct? And
Yes.
reduction, we have 3Ag plus, okay,
Okay.
plus 3 electrons because it has already been 3, so I'm not changing the numbers, okay?
Okay.
And we get
So aluminum went through
oxidation,
oxidization,
oxidation.
and silver went through reduction.
That's right. Okay,
Mm. Okay.
so that's one part. Now That's done. Okay. Uh, Let us understand what the oxidation
Oxidation numbers.
numbers are.
Okay.
Okay, and this part you can do later on, like you can identify a balanced chemical equation. Okay, that you can do later on.
Okay.
Hello?
Yeah, I'm here. I'm here.
Yeah. So oxidation numbers. So oxidation number, a number used to keep track of electrons in oxidation reduction reaction according to certain rules, known as oxidation state. Okay.
Okay, already done. You can continue.
Done. Okay. Now check the
Yeah.
example that has been given. In the molecule of water, oxygen and hydrogen atoms share electron. The oxygen atom is more electronegative, so it has a greater attraction of the electrons than the hydrogen atoms do, right?
Yes.
Okay, so now if you have to assign the oxidation number, okay, so hydrogen, right, has an oxidation number of +1 and oxygen has an oxidation number of -2. Okay, why? Now let us understand that. So if you look at the position on the periodic table, oxygen belongs to group number 16, right?
Yes.
Okay, hydrogen belongs to group 1. Group 1 means 1 valence electron. Group 16 means 6 valence electrons, correct?
Yes.
So in order to complete octet or duplet for hydrogen, it can either take one electron or it can either lose that one electron. So it's even. So it has equal, what do you say, a probability of losing or gaining electron. Make sense?
Okay.
Right? Whereas in case of oxygen, there are, it has to lose 6 electrons or it has to gain 2 electrons. Correct?
Okay.
So
Okay.
either it can lose 6 electrons or it can gain 2 electrons. What according to you is easy?
Two.
Gaining two, correct?
Yes.
So this is more probable. So
Yes.
oxidation number of oxygen is -2. Whereas hydrogen it can be +1 or -1. But
Okay.
if hydrogen is combining with oxygen, which is a non-metal,
Okay.
so it will definitely be +1.
Okay.
But if hydrogen is combining with a metal, it will be -1.
Okay. So even for like uh elements with the +4 or +4 -4, right? They only have 4 electrons, the valence electrons. It depends on what electron they're what
Yes,
atom they're merging
correct,
with.
correct.
Okay. Okay.
So whether they are like with a metal or a non-metal, that will
Okay.
be a deciding factor.
Okay. If they're with a metal, they'll probably lose electrons. If they're with
No, if they
no,
are
no,
with a
no, no, no.
metal,
They'll
they'll
gain
gain
electrons.
electron.
And
Yeah,
if they're with the thing, they'll lose.
yes,
Metals are more likely to give
right,
electrons.
correct.
Okay.
So now the oxidation number, these are certain rule. Now one of the rule is oxygen is always -2. Because it is electronegative, it is always -2. There is an exception when it is a peroxide, where it is -1.
Sorry, you cut out. Could you repeat that?
Okay, I said oxygen is oxidation number of oxygen is always -2.
Okay.
Exception
Okay.
is peroxide, H2O2, hydrogen peroxide. I'm taking example.
Okay.
Only in this product, when it is a peroxide, it is
Yes.
-1. Otherwise, if you see oxygen, it is -2. But if you see H2O2 or any what you say, benzoyl peroxides are also there. So like any peroxides are basically oxygens are combined together.
Yes.
Okay, so they are connected to each other, then these are peroxides. So only in this condition, when they are peroxides, it is -1. Okay,
Okay.
so what you need to remember, oxygen is always, when it is
Oxygen is
when it is in a compound, oxygen
always +2.
-2,
-2.
right?
Sorry.
Okay,
Yes. As in they'll need two electrons to complete.
yes, right. Now the best way to remember the oxidation number is look at the group number. Okay,
Okay, okay, okay.
except for the transition elements. Now, for example, if you see over here, right, sodium is +1,
Yes.
right, because it is easy for it to lose one electron.
Yeah.
Chlorine is -1 because if you see the group,
Easier to
uh
gain. It's at
yes,
7.
7,
Group
so
7.
it's easy to gain one electron, so it is -1.
Okay.
Okay, then there are transition elements. We will try to restrict them for now. We will try to ignore them for now. Okay,
Okay.
so those are unassigned. We need to understand how they. So if it is unknown, we'll try to understand how to assign the oxidation numbers for those. Okay, so let us take
Okay.
the example over here. So let us take the NaNO3. Okay, here. Okay, so for NaNO3, nitrogen, we'll try to determine the oxidation number. Okay,
Okay.
so how do we do that? So we have sodium, we know is +1,
+1.
right? And there is one of
Oxygen
it.
is
Ha-
-2.
Nitrogen, we don't know. So we'll write it as X. And there is one of
Oxygen
it.
-2.
And oxygen is -2.
So it'll
And
be
there are
three of them.
three
So it's
of
be
them.
-6.
So,
Okay.
and summation of that is 0.
Okay.
So
Wait, what's
plus
0?
the summation, this is neutral. The compound is neutral.
Okay, okay,
So
yeah,
the
yeah, in
overall
total.
charge is 0. Okay.
Overall charge is 0. Okay.
So we have +1 plus X -6 is equal to 0.
So you
Okay.
just rearrange it. Okay.
Yes.
X can
So
be 5.
X is +5.
Okay.
So nitrogen is +5.
Okay.
Okay. Can you try carbon in Na2CO3?
Okay. It's gonna be 4. It's gonna be +4.
It's +4.
Yes.
Okay. Mm, carbon X, nitrogen is +2, 6. Yes. Okay.
Okay.
Then try Cr2 in K2Cr2O7.
For what?
B, fourth B.
Yeah, but which one? Which?
Cr2,
Okay,
Cr2.
CR2. Okay, okay. This is tricky because
Yeah, go
actually, wait,
ahead.
no, 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 no. This is gonna be 6 +6.
+6. Okay.
Yeah.
So it's 2 into 1 and X, 2X plus uh, 2 in -2 into 7. Yeah. Okay. So that is understood,
Yes,
because
yes.
that is the most important part in order to understand the half reactions and the other stuff. Okay.
Okay.
Mm. Let us go to the next oxidation number. Okay. So now In this, can you identify which are undergoing oxidation or where there is a change in the oxidation number in A? Like let's do B, 1B.
And these are okay. Okay. Uh,
So we have
um, my
4.
periodic table. Okay, I can do it. Okay,
I
on my
didn't tell
periodic
you.
table. Wait, I have a question. On my periodic table, it says Fe iron +2 or +3. So
Yeah,
I just do +2, right?
no, no, that's not the way. Okay, so when it is, I didn't tell you this rule earlier. If there is a element on the periodic table in its natural state,
Okay.
okay, the oxidation number is 0.
Okay.
Okay,
Okay.
so
Iron
oxygen,
is
half
all
Brinkel,
solid.
so it will be 0. Iron, solid, 0 in its
Okay.
natural form. Correct? Now here
Okay.
it is easy. You have oxygen, you can identify iron. Oxygen is always -2,
So all elements in their natural form are
0.
0. Okay.
Yes.
You can continue.
Okay, so are you done?
Yes.
Okay, what is the charge on iron?
It's gonna be the same.
How much?
0.
No,
No,
on the
no, no.
right hand side.
+2, +2.
Sure,
No.
find it.
Okay. If it's
So it is 2x plus 3
-6.
minus 2 is equal to 0.
It's gonna be
So
3.
it will be plus 3.
+3, yes.
Okay, so now iron is undergoing change, oxygen is undergoing change. Iron is losing electron and oxygen is gaining
Oh, this is
electron.
basically rust.
Yeah, this is basically rust.
Okay, okay, okay. I
So,
understand.
anyways, we are not interested in that now.
Okay, okay,
We'll
okay.
talk about it later. But
Okay,
here, what I am trying to tell you is identify where there is loss of electron and where there is gain of electron. So, you
okay,
know that here there is loss of electron, here there is gain of electron, right?
okay.
Am I able to recognize gain of electron and loss of electron?
Yes.
So, that means this is oxidation, this is reduction. If
Okay,
this is oxidation, means this is a reducing agent,
okay. And
correct?
iron is a
So,
oxidation agent.
no, iron iron is the one that is losing electron. Prahlad, this is loss of electron, right?
Yes.
And hence that is oxidation.
Okay, so it's a reducing agent.
This is a reducing agent, yes,
Oxygen is a Okay.
correct.
Yes.
And this will be a oxidizing agent. So whatever undergoes oxidation is a reducing agent. Whatever undergoes reduction is a oxidizing agent.
Okay.
Okay, can you do it for 1A?
1A, okay, I'll do that. It's gonna be -1.
Sorry, I'm not
Minus
asking
one.
you about. I'm not asking you about the charges.
Okay, okay.
I'm asking oxidation and reduction.
Okay,
So can you
a
notice the change in the
yes,
oxidation
yes.
numbers?
Yeah. Silver is the silver is experiencing oxid not oxidation reduction, and silver is the oxidization agent.
Okay. What I do, please pay attention what I do over here. I just write GER.
Okay,
Okay, why? Because I know that iron from a positive charge has become zero. Sorry, silver from a positive charge has become zero. That means it has gained electron. That is
okay,
GER, right? That
okay,
means oxidation. And copper here, if you see, from zero has become plus two. That means it has loss of electron, correct?
okay. Yeah.
So reduction, reducing agent, sorry, correct?
Yes.
Okay, now try and do it for 2B. Identify where there is change in the oxidation number.
Okay. There's change for zinc.
I'm asking you 1B, 2B, sorry.
2B.
Yeah,
There's change in oxygen. Oxygen is reduced
why oxygen will be reduced? Check again. Check the
because it go.
oxidation number. First, don't try to do it mentally.
Okay, okay.
Okay, write down the oxidation number on top. Okay, and then try to move there. What you are trying to do is
Never
you are
mind.
trying
It's
to just jump.
I'm still mixing up reduction and oxidization. It's oxidized because
Okay, wait,
it
pay attention.
loses electrons.
You don't try to jump the gun, right? We have Sn to SnO2, correct?
Okay,
Solid plus carbon solid. Write down the reaction, right?
okay.
Plus CO2 gas. Now, tin here is plus 4. You agree?
Yes.
And here it is minus 2. Oxygen will be minus 2. Carbon is 0, elemental form. Tin here is 0, elemental form, right? Natural form. Carbon will be plus 4. Oxygen will be minus 2. So if you
Okay.
notice, oxygen there is no change on both sides. So you'll ignore them.
Okay.
Okay, now pay attention. Tin has changed from plus 4 to 0. Carbon has changed from 0 to plus 4. 0
Okay.
to plus 4 means loss of electron. Plus 4 to 0 means gain of electron. Correct? Loss of
Yes.
electron is oxidation. Correct?
Yes.
That means reducing agent.
Okay.
Gain of electron means reduction. That means oxidizing agent. Write it down. Okay.
Yeah, I
So
wrote it
we'll stop
down.
over here and we'll continue in the next class. And please, next time, please join early. Okay?
Okay. Okay. Sorry. Yeah. All right. Have a good day.
Yeah, you too. Bye.
Bye.